See, I generally don't call it as formulae, but yes, you can use them. Suppose these are all actually the equations. Okay, actually they are equations of particle in a section. So if I talk about displacement, okay, if I talk about displacement in terms of time, in terms of displacement, then here it will be y is equal to a sine omega t, and the displacement is simply y. If I talk about velocity, then v will be equal to a omega into cos omega t in terms of time, whereas in terms of displacement, v will be equal to a omega into root of omega square minus y square. So similarly, can you guys tell me what would the acceleration be, which I derived in the previous class itself? That is, you need to differentiate a omega cos omega t. It will be minus omega square into a sine omega t. That is in terms of what? In terms of time, because I want time to be here. Whereas if I write it in terms of displacement, it will be minus omega square y. Am I clear, guys?
Yes, sir.
Okay. This is all about a particle having a vertical simple harmonic motion. See, I don't want to use the word vertical. To put it in simple terms, a sine omega t or a cos omega t, both are right. Okay. If suppose in your school they teach in terms of a cos omega t, just accept it. That is also right. So depending on the question, you have to do it. Okay. Similarly, when I talk about the displacement, velocity, and acceleration for a particle which is moving along x direction, the x will be, you guys tell me, a cos omega t. I hope you are able to understand the difference by now.
Yes, sir.
Okay. So this here we call it as x. Then what can you say about the velocity? It is minus a omega. Tell me, minus a omega sine omega t. What will be the velocity in terms of displacement? You tell me. Minus
a omega root of omega square plus x square.
Not plus.
Minus, okay, sir.
It is still minus only. Okay, what about the acceleration? Minus omega square a cos omega t. And here it will be minus omega square x. So this is the outline, guys. A very, very, very important factor to be understood for you to differentiate between oscillations. And next chapter, you will have this expression to be one more big. Okay, in waves. You need to have a clarity in this chapter for you to understand the next.